made this video a couple months ago for another guy's channel, and then he ended up taking a break from YouTube and didn't use it. But I thought this was a pretty fun little build, so I decided to toss it up on my channel rather than just having it die. For this video, I trained a very basic linear regression model to predict the future price of Apple stock a few days in advance. Obviously, if you're building a bot to trade actual money with, there's a lot that goes into creating something like that. But the goal with this was to learn the basics of working with Kaggle datasets, Jupyter notebooks, Lumibot, and the scikit-learn library for machine learning work in Python. So feel free to code along if you want, and I'll link the GitHub repo in the description as well. We're going to be creating a simple AI trading bot today. And step one is going to be to get set up using Jupyter Notebooks. Jupyter Notebooks is an awesome tool for sharing Python code, so it's a great way to work collaboratively. And it's also going to make it a little bit easier for us to have some visualizations with what we're doing. So the goal of our bot is going to be able to predict the price of a stock a few days in advance as closely as we can. And for this purpose, we're going to use a basic linear regression model. If you're going to be doing machine learning, you need to have an algorithm that you can train your data on. And so linear regression, basically it boils down to predicting a particular future data point based on a previous data point. So that's all you really need to know for this. But there's always more you could build onto this if you want to create a really robust financial model. Okay, let's go ahead and set up Jupyter Notebook. Now it's going to be important that you do have Python installed on your computer for this, of course. If you don't have Python installed, you can install it with Homebrew on a Mac, or you can also come to the download page here and install it for whatever operating system you're using. Once you've installed Python, you should be able to check by using the -- version flag what version of Python you have installed, and it should tell you right there, so you know you have Python set up and ready to go. Then we're going to use the pip command to just install Jupyter Notebook into our project. So we'll just copy this command here. We'll just paste the command in. Once that finishes, we should just be able to use the command Jupyter Notebook, and it will run the notebook for us. So let's try it. Perfect. It opened this right up for us in localhost. So before I go ahead and create a new notebook in here, there's a couple things we need to take care of first. There's some Python packages that we're going to need to use for this build. So I want to go ahead and install those before we create the project. So we'll use the pip command again, our Python package installer, and then we're just going to install a series of packages that we're going to need for this build: pandas, numpy, matplotlib, seaborn, scikit-learn, and lumibot. So we're just going to install those into the project. Now the critical thing that we obviously need in order to do a machine learning project of any kind is data. So for this build, I found a NASDAQ daily stock prices dataset on Kaggle. And Kaggle's pretty cool because they have lots of free public datasets that you can just grab and use in your own project. So this is what this dataset looks like. It's basically a CSV. They have open, high, low, close tickers for a whole bunch of different stocks. You can see over here, you can choose from, and there's data going all the way back to 1962 through the current day. So we can download this dataset to use for free to train our model on historical NASDAQ stock prices. So I'm going to go ahead and download this dataset. We'll unzip, and here it is. We now have all these CSV files locally on our machine. So now what we need to do back in our Jupyter Notebook is use pandas to point to the CSV file with the data that we want to use. Let's go ahead and create a new notebook. We're going to use Python 3, and let's call this AI Trading Bot. The first thing we need to do is import the pandas package that we installed. So we'll do that at the top. Then we're going to use pandas to just see if we can successfully read the CSV data from the Kaggle dataset that we just downloaded. To do that, we just need to feed our file path to pandas data frames. We'll use pd.readcsv. I'm just going to put in the path to where this file lives on my computer. So I have this in my downloads folder inside a folder called archive, because that's the folder it was in when we downloaded it. And I'm going to use Apple stock for this project, just nice blue chip stock. So let's just see if we can print this result. So if I just say print data frame and then run all cells. So we're able to successfully use pandas data frames in our Jupyter Notebook to read this output from our Kaggle dataset CSV file that we have saved to our computer. The next thing that we want to do is we want to convert the values in this date column to be of type date time, okay, because we want to be able to use these as an index. So there's just a little bit of data pre-processing that we need to do here. So right after we use pandas data frames to read the CSV, I'm going to add a line here, which by the way, at least on Mac, it's Control-O to add a new line within a Jupyter Notebook cell. So just quick note there if you didn't know that. We want to target that column, just standard Python syntax for that. And then pandas data frames has a toDateTime function that we can just use. Then we want to set this column as an index. So we'll just use dataframes.setIndex for that. And we want to do this for a few reasons. One is that having the date as an index just simplifies time series analysis, so we can filter, slice, resample the data more easily based on time intervals. So it's just going to make our analysis a little bit easier. Plus, pandas offers a lot of built-in functionality that's easier to work with when the date is set as an index. So when we use our chart plotting libraries, Matlib and Seaborn and stuff that we're about to do in a little bit, if the date column is indexed, those libraries automatically recognize that as data points that we want to plot on the x-axis. So this is just going to make life a lot easier. I think there's one more thing that we should do here for some basic pre-processing, and that is just to handle any missing values. Now, I don't think that there are probably any gaps in this data set, but just in case, we can prevent any errors by making sure of that. And the method that we're going to use here for that is just going to be a simple forward fill. And all that means is we're going to do a carry forward. So if there's a gap, we're going to use the previous record's value and just carry that over and use it in place of the gap. And just for clarity here, I'm going to add some quick comments so we can keep track of what each piece of code is for as we go through this. This is going to be loading the data set date column as index, and then handle any missing values. So that should take care of some basic pre-processing. Now let's move into what is known as some exploratory data analysis. Here's where we're going to start using our visualization libraries so we can get a better idea of the data we're working with, because you wouldn't really want to trade on something without being able to have a good idea of being able to see the trends of the asset that you're working with. So let's import our matplot plotting library. And now instead of just printing the data in a table like this, we're going to see if we can actually have it plot onto a chart here. So let's go ahead and plot all of our closing prices. So let's just start with this for a size for our chart, and we want to plot the close column, and we'll label that closing price for clarity. And we'll call this chart Apple stock closing prices over time, because this is time series data. And on the x-axis is where the date's going to go, like we said, so we'll just label that. And on the y-axis is going to be our closing price, so we'll just label that price. The only other things we need are just, we'll go ahead and show the legend. Okay, let's see what happens if we run all of these cells that we have now in our Jupyter Notebook. Okay, so this gave us a blank chart. It does have the labels that we gave it, but oh, that is because I am missing, I put the column name, but I didn't reference the data frames there. So we just need to add that. Run all the cells, and there it is. So overall, obviously, pretty good stock pick, right, over the long term. And it's a lot easier to tell that, a lot more obvious to see that by looking at it right here in the chart than it was just by looking at all those little numbers that we had printed in the table. Now that we successfully have our data set and we've been able to plot the data into a chart so we can visualize it, we need to start developing our actual machine learning predictive model, because what we want to do is actually predict some future prices of this stock. So we need to develop our strategy for that, and then we need to backtest it. Backtesting is very, very important. It basically lets you see how the strategy you developed would have performed over time with the data set that you have. So once you develop your strategy, you need to test it with your existing data to see how accurate your model would be. And that can give you a lot more confidence in the future predicted price points that you don't have a comparison for. First thing I'm going to do is just import some more tools. I'll just paste these in here. As you can see, we're going to be using the scikit-learn Python module, which is used for training data and machine learning with Python. So the strategy that we're going to be using today is we're going to take a simple moving average and use that in a linear regression model. Linear regression is basically just a model that estimates the linear relationship between different outlying data points. So if we look at some images here, this is a pretty good basic example, right? It's just estimating the linear relationship between all of this data. So you can obviously get a lot more complex and account for a lot more different scenarios and things in your models, but this is a pretty straightforward, no pun intended with linear regression, model that we can use for this example. The first thing that we need to do is create a simple moving average column in our data frames data set. And all this means is that we're taking the average closing price of this data set over a specific time. So we're just calculating the mean here. Now, one other thing that we'll want to do in order to make sure that this gets calculated correctly is we'll want to make sure that our data set is in the correct order. So we've already indexed it by date, but we want to make sure that it's sorted correctly in time order so we don't end up with plot points all over the place. So all we have to do for that is just a sort index. We'll just throw that on there to be safe and make sure our data set stays in the correct time order. All right, and then here we're calculating our simple moving average. Now, once again, as we always have to keep in mind working with data sets and pre-processing, is we need to make sure that we account for any scenarios where anything's missing or isn't of the correct data type, because those things can cause errors. So we just need to handle that before we even go any further, just so we don't have to worry about that. We want to just go ahead and drop any rows where our simple moving average is not a number. df.drop_na. Now we know no matter what, we're always going to have the data we're looking for. We're not going to have any empty records or records that are going to throw an error, so we can go ahead and assign our x and y values. We're going to set x equal to our simple moving average, and y is going to be equal to our closing price, because remember, we're basing this off of the close price for each day. We've calculated our simple moving average, we've handled any edge cases, and we've defined our x and y value sets. Now we need to define our training and test data. This is an important part of developing AI models. We need to be able to use some of our data to train the model, and then some of the data to test the model that we just trained and see how well it actually works. So that means we need to split our data set into training data and testing data for X and Y. And because this is time series data and order matters, we want to go ahead and define a clear split point. So the next step is going to be split time series data. We're going to need an X training set and an X testing set. And then we'll need a Y training set and a Y testing set. We'll just define our split point here as a function of the length, and then divide up our X data based on that split point for the training set and the testing set. We're at the point where we can actually define and train our model. So next step is create, train the model. So like we said, the model that we're going to be using is a linear regression model. So we imported that here from our scikit-learn library, so we can go ahead and just define the model using that right here, linear regression. Then we can just call model.fit and pass in our training data that we just defined up above for X and Y. All right, so this is going to initialize our model and train it on the data that we have. Once we've trained the model, we then want to use the test set of the split data to predict and see how accurate the predictions are compared with where the actual data points fall. So our next step is the predict and evaluation step. Now we can call our model that we defined here and just say model.predict. This is why the scikit-learn library is so nice and handy, and we're going to give it test data. Now there is one other value that we can calculate here that is kind of nice to see when you're doing calculations like this, and that is our mean squared error. This is really more of a math thing since we are using linear regression here. Mean squared error is kind of like your margin for error. It's like taking the standard deviation. So if you end up with a low mean squared error, it means that your predicted values are very close to the actual values. So that would be a good thing in this case. So we can go ahead and just print out our mean squared error value here. That's something that also comes built in with scikit-learn because that's just kind of a nice thing to see. It's kind of another way to like measure the confidence that you can feel in your predictions. So we can print that value and that will give us some insight, but ultimately we really need to be able to visualize this, right? Because just like we did with our data set here, it's really hard to just look at numbers and really understand and get an idea of what you're looking at. So we want to actually plot these predicted values alongside these actual values, and that'll be a lot easier for us to see how accurate this prediction model is going to be. So let's just create a new plotly chart. This should be pretty simple because we've already figured out how to use the matplot library and make it work right here. So we can basically just copy this and I'll comment that out, and we're going to make a new chart underneath it that's going to be the predictions versus the real values. Here we're going to have still our actual price data, but we'll change the label to be actual prices. We'll change the title to be actual versus predicted. We can leave these labels as date and price, but then we want to have one more line that we're plotting, and that's going to be our predicted prices. So we want to plot 2 lines on this chart. And we'll plot this one in red for contrast. All right, this was a big chunk of work that we just did and just added to our notebook here. So let's go ahead and run this, run all cells. Oh, we have a typo right here. I accidentally put a dash instead of an underscore. Okay, let's try it again. Another typo right here. Okay, let's run it. And there we have it. So the blue line is our actual prices and the red line is our predicted prices. So as we can see, they are pretty spot on. So that's pretty good results for our backtest data. Now this chart is showing us data over a pretty long timeline. So if we were to zoom in a little bit closer, we would probably see some of the discrepancies and slight differences on these data points a little more clearly. But we can come up and look at where we printed our mean squared error, and we can see that we have a value of 3.9. So that's a pretty low number and means that overall our values are pretty close to the actual data points. So that can give us some confidence about using this simple moving average model to now go ahead and try to predict some dates in the future that go past the end of our data set here. Obviously, backtesting is really, really important. Another way I want to just really quickly mention that you could use to do backtesting of your data is using a tool called Lumibot. I think it's worth mentioning just because this Lumibot library is really, really cool and can give you a lot of really helpful data for your backtests. It does work with pandas data frames, but it's a lot trickier, so I don't think it's going to be the easiest for our use case. But if we did want to use this to check out some data for the Apple stock that we chose, it's really easy to just use data sets that Lumibot can pull directly. So we're using Yahoo data backtesting here, and we just pass in the stock that we want and the price that we want. This is just copied directly from Lumibot's documentation. So the trading strategy that they've defined here is just buy and hold. So it's just going to buy on the first day, show how you would perform with that strategy over the whole history of Apple stock prices. So if we run this, just to show you what this would look like, it's cool because we can see the portfolio valuation. It starts you by default with $100,000, and it shows how that value changes as it makes progress through the data set. So we're up, $4,000 right now, and you can kind of just watch that number tick by while it processes. So when this finishes, it's going to output some data here, and it's going to open up a couple windows for you in the browser. This chart here is going to plot all the trades that you made. So this was a buy and hold strategy, so we have one buy here at the beginning, but it would plot those points for everywhere that you bought based on your strategy. And then you can see how your strategy performed versus the SPY, which is right here in the red. So Apple stock is a little bit down right now. So over a short time window here of just a couple months, the portfolio we can see is down a little bit. And then it gives you a full breakdown with all of these stats about your strategy and how it performed, what the risk is, and what your overall cumulative return was. So overall, we were down 4% over this time span. So I just wanted to point this out because it's a really valuable and awesome tool for backtesting. So if you want to dive further into backtesting with different trading strategies that you have, I would highly recommend this as a great way to do that. However, for this project, what we want to do is actually predict stock prices in the future based on a data set. So let's go ahead and add that piece into our project now. So now is when we really get into the weeds of some machine learning algorithm stuff. We're going to use something called model-based recursive forecasting, which means that we're going to use the predictions of the model itself to forecast the simple moving average for the next day. And then we're going to use that forecasted value to calculate moving average for the next day, and so on. We'll come right here where we train the model. And our next step that we're going to add in here is going to be predict next 3 days of prices using model-based recursive forecasting. So we're going to want to take our last date in the data set, and we can just do that by grabbing index -1 from our data frame. And then we want to define our future dates to have a data set that starts from the next day. So we pass a date range to pandas data frames. And we want to predict 3 periods in the future, and this is daily data. And then same thing for the simple moving average values. In addition to the dates, we're going to be starting with the last known value. So all this is really doing is defining that we want to start at the end of where our existing data set ends and go 3 units ahead into the future, 3 days into the future. Here's where we need to actually recursively predict the next 3 days. We're going to create a loop for this, and we're going to use the last day's SMA value to predict the next day's closing price. So we can use model.predict again, pass in the SMA value. So we can predict the next day, but now to predict the next day after that, we need to shift the time window and add the newest prediction. So let's do that. So we want to get the last 4 actual closing prices and calculate the new simple moving average for those. This might look like a lot. It's really just taking an average, right? Sum of the last 4 days plus the predicted one. So a total of 5 values divided by 5, and we're getting the new simple moving average here. And then we need to just append this new value for future predictions. So we'll just append it to our future estimate values array, which is up here. And actually there's a typo there that I see. And we're just gonna append our new simple moving average. So now the last 3 values of our data set are going to be our predicted values. We're going to define these future predictions. And really quickly, we're just going to exclude the first value, which is the last known SMA value. So we don't want that included in the predictions because it's a known value. So let's just see what would happen if we wanted to print our future predictions here. Let's just run this and see what happens. Oh, we didn't indent the for statement. All right, so we can see this was successful. We do have 3 new stock price predictions printed out right here. So this means our little recursive model is doing what we expect it to do. And we do have the data that we expect here. So if all you needed was the data, you could stop here. But as we've seen throughout this project, it's a lot more helpful to be able to visualize this a little bit better. So let's just see if we can quickly plot this onto a chart like we've done with our other prediction values here. So I'll comment this out. And what I'm going to do, since we're only predicting 3 dates ahead, is to plot this out. I'm going to take a smaller subset of the data, because if we plotted 3 more days on here on this chart that's showing us like 10 years worth of data, we wouldn't even be able to see it, right? It would be such a tiny little blip, so that wouldn't be helpful at all. So let's just take like a month's worth of data. So we'll be a little bit more zoomed in scale-wise, and we'll be able to see those new 3 data points that we just created. Once again, we can copy a lot of what we already have with this matplot syntax. Copy these. We're going to call this stock prices last month with 3-day forecast. But then for the first line, we are going to just plot the last 30 days of our data frames data set. So we can just pass directly in our data frame index -30, close column index -30, and we'll label it historical prices for the last month. And for our second line, we want this to be our 3-day forecast line. So we're going to pass in our future dates and future predictions that are defined right up here, and we'll have this a green line. So let's compare and see what this looks like. If we run this now, so here it is. We have a nice smaller slice of our data set, and then these 3 little green dots are our new predictions. Now, if you're wondering what this gap is here, it's because these are weekend days. And the market is obviously closed on weekdays for traditional stocks. So that's why there's no data points here. And the reason you don't see gaps in the rest of it is because it's just one single line. So the places where there would be weekends, they just drew a line to connect where the dots were. So if this was all one single line, we could have a line going between here and here if we wanted to. But we can see that our model predicts how this pattern of the Apple stock price is going to continue over the next several days. And of course, if you wanted to predict longer in the future than 3 days or some other time period, you could just come up and make some adjustments in the code here, right? Change the periods, number of iterations of our for loop, right? Just adjust some values here, and you could predict, as many days in the future as you wanted to using this model. Alright, you made it to the end. Thanks for watching. I hope you learned something. Subscribe to my channel if you want to keep up with these videos that I post somewhat periodically, and I'll see you in the next one.